this particular Python code that you can see here is basically have kept just to show you, if I really want to do linear regression, you don't need to actually write code from the scratch. You have a lot of packages available and you can use that. But why I have shown you the code from scratch? Because there is some certain situation maybe in future you will face that you need to create your own logic by your own way. In that case, there will be no package available. You have to write your code by your own way. So you must need to understand what exactly you have within what's running within the function. That's why I have shown you the code from the scratch. Okay, let's start from here. So we just have one more file here just to show you what data exactly present here is something like this. Okay, so there are actually very few points here, as you can see, that it's hours versus some scores. Okay, and this hours is basically your x and score is basically y. So with respect to some specific hours, you have to find what should be the score. That's basically we are trying to develop a machine learning model, a linear regression model specifically saying, which basically can capture the relation between these hours and scores from this data. That is what we're doing. So let's just do a scatter plot here, trying to understand. You will be able to understand. You see, it's not exactly on the straight line, never it happens, but you can easily understand there is some linear relationship present. Some compromised level, you can create a linear relationship. You can draw a straight line, something like this, right? Now you see that if you just try what I have done here, I have basically extracted the scores and hours as x and y here. Okay, x and y here, which is basically something like this. And then what we have done, we have basically here we have used a model here, right? As you can see, so the model is something like this is a specific function, basically you can say, present in the sklearn package under model selection class, which basically splits the data. Already you have seen this function in my previous classes. I've shown you how to split this. So it's not it's a simple train test split, not a stratified train test split, right? I hope you can remember. So let's do one thing. Let's just you know run this code, and so you have got x train, x test, y test. If you print all this, you will get this, right? And what this test size is representing, this test size is representing how much data you will keep as a test data, how much as a train data. That means 0.2 means I will keep 20% as test data, 80% for training. Okay, so now what I have done here, we have just created a regression, linear regression object. Okay, an object of this particular class, linear regression class. So that we have done here. And then this regressor dot fit, this fit function, actually what is the purpose of this fit function? Once the fit function will be called, the you know the it will try to fit a straight line that can best represent the x train and y train. So one thing you can remember, you can try to understand from here, that just based on the lecture that you have seen in just in previous class, so over there I wrote a code from scratch for this fitting. So once you call this fit function, that set of code actually running behind, which you are not able to realize if you Don't write from the scratch. Anyway, so let's call this, and you see it's just fitting and taking very small amount of time. Remember, I have not uh, initialized any number of iterations and learning rate and anything, right? I have not initialized any parameter. So this particular algorithm is creating those values by itself. Maybe you can change in your own way if you want. So if you see that intercept value is 3.12, it's nothing but the m that basically you have observed in previous code, and similarly this coef is nothing but the you can say the bias, or not bias, sorry, it's slope, right? So this is 9.60. Now what you can do, you can basically try to find the score of this. So if you just see, its score is 94.36. What does it mean? It means actually it is basically calculating the score with respect to the slope and intercept on the data. Okay, and now one thing we can do, we can try to predict what exactly value should be for a particular data, input data. So that is also possible here. So for a particular data it should be 94.36, something like that. Okay, in the same way, actually we can also use this particular function. You see here, if you call this regressor dot predict, this predict function actually predicts each and every y for all the data present in x test data. Okay, okay. So if you just print y pred here, you will see, you will find multiple prediction value. Why? Because in X test you have a 20% data. I hope you can remember. Test size was 20%. So 20% of 24, total 0 to 24, total 25 data, and 20% of 25 is nothing but just 5, right? That's why 5 test data was present. So corresponding 5 predicted y found. That is what this predict function is doing. It's predicting each and every value of x test and stored in ypred as a list. Okay, now you can simply just try to print this, just same thing, actually just checking. You see actual was 54 in my y test. Over here you see in my y test, and the predicted one is 49. Maybe you can say that no, it is not properly learned, right? Obviously, because data is very limited, only 25 data, and among 25 data I am basically training the model with only 20 data, which is literally insufficient for a training. Okay, so that's why definitely it's not properly learned, but I hope you can understand that once you will have a very good amount of data, it will be easier to learn in a very good way. So this is how we can actually find the change, the difference that basically you have in actual and predicted. In the same way, basically you can try to find out the errors also, the errors with respect to mean absolute error, mean square error, and root mean square error. Okay, how we can do that? We can simply call mean absolute error and mean square error function, which is present in the, I hope which was present here. So that mean uh, that mean so if you just run this particular code, let's run it, so it will be easier to run. Then if you print this, you will get these values, you see. So in this way, basically you can create your own model, then you can check how good your model is. Definitely here the mean absolute error, square error, root mean square error is very high, which should be less than 1, but here it is this one because of lack of data. If the data is huge, then definitely this error gets minimized. But this is a way by which you can create your own linear regression model using scikit-learn package like this. So this is all about the Python code of linear regression using using the scikit-learn package. And already you have seen how exactly the gradient descent function is working from scratch. So this is all about the linear regression. Now what we can do, we can go further and we can go next algorithm, that is what we call logistic regression.